Let's run the code. So let's go for a male name between 4 and 7 of second order, and let's generate 10 names. And here we have a list of names. And then if we do female names between, let's say, like 8 and 12 of first order, and let's do 10 names again, we have a bunch of just very, very, very weird names. So I wrote this in Python, so we're going to use Notebook to look at the internals of how this is working. In this case, I start a BabyNamer object of girl names of order 3. I read in the file, and then I subset this into a list of 50 names and just one name to kind of show it better. So the one name I chose is Zoe, and then the subset is the first 50 names. I first clean the names by essentially just removing the new line, putting everything to lowercase, and adding leading and ending blanks. And I wrote that as map, so I can do that, apply that to a list of names at once. And here I get that subset of clean names. So for the most interesting thing about this is how I create and count the transitions between letters or states. So I do that by first taking a single name and creating n-grams between order 1, or n-grams with n of between 1 and the order. So for the less than order lengths, I filter to only have the leading blank in there, and then for everything else I just have n-grams of order 3. And so what I do is then from this list, I figure out what the next letter is for each of these specific n-grams and add that to a dictionary with a list of ones appended, and show this. So in this case, blank is followed by Z one time, so on and so forth. More interestingly, when you apply this to a bunch of names, you get then across all of the names, each occurrence shows up as a 1, as a count of 1 in this list. So what I do to this dictionary then is I make it a little bit more easy to use and transform it using this unravel method that I have, which essentially creates from this current dictionary a dictionary where the key is going to be the sort of current states, and then the value is going to be a list of next states associated with the total count. So I sum up all of the ones in the appended dictionary. So to show that in action, here we go. So what this means in this dictionary is, for example, the starting combination of blank followed by an A. The next letter is A once, B 8 times, D 14 times, I 5, K once, and L 21 times across the 50 subset names that I gave it. And then it becomes pretty easy to transform this dictionary of counts into a frequency, essentially by, for each current state, summing up the total values that occur, so all of these numbers, and then for each value dividing it by that total. So if I show that, I've transformed then my count table into a frequency table, which is then used to generate names. So finally, I generate a name based on that transition table that I trained on the subset. So starting out with a name that starts with an A, the current state is just going to be those first 2 letters, and this is just as an example, but I look up into the transition table the row of possible next letters corresponding to the current state, and then that brings up a subdictionary right down here where the possible next letters are going to be the keys of that subdictionary, and the frequency distribution of those next possible letters is going to be the values of that dictionary. And I use NP random choice to choose from the list of possible next letters one letter according to the frequency distributions current in the training set. And then I just keep doing that, modifying the current state as necessary until I get an ending blank, which shows the end of a name.